Hi, my name is Miss Murray, and in this lesson we're going to be talking about analyzing lines of fit. We have 3 learning targets. The first one is, I can use residuals to determine how well lines of fit model data. Secondly, I can use technology to find lines of best fit. And third, I can distinguish between correlation and causation. So let's turn our attention to the first learning target, analyzing residuals. So the first thing we need to understand is the definition of a residual. A residual is the difference of the y value of the data point and the corresponding y value using a line of fit. So the difference between a y value of a data point and the y value using a line of best fit. So residuals can be positive, negative, or 0. For instance, if a data point lied right on our line of fit, its residual would be 0 because there would be no difference between the measured value and the value that we get from the line of fit. This point right here is a positive residual because the measured value, or the thing that the data point that we measured, is bigger than what our model predicts. So this would be a positive residual. This point down here would be a negative residual. Because the data value we measured is lower than what our line would predict. So we can actually graph these values, right? When we talk about residuals, we're actually talking about the distance from the point to the line here. So if we graph those residuals, we can determine if a line is a good fit. Okay, so if the residuals are random, the line is a good fit, right? Because that would mean that we would have random points all along this line, okay? Now, if the residuals show a pattern, then the line is not a good fit. So let's take a look at these graphs of the residuals. For A, these residuals are random, right? There's no clear pattern to them. So this would be a good fit. In example B, there's definitely a pattern here, right? We can see that we go in this kind of pattern right here. So this would not be a good fit. And similarly, for C, we have this pattern right here. So that tells us that our linear model is not a good fit. So let's look at an example here. Okay, what we have is the equation y equals negative 2x plus 20, which is going to model our weekly sales of a certain DVD. And we want to determine if our model is a good fit. So what we're going to do first is we're going to use our model to find our predicted value, okay? And we do this simply by putting our x values into our model. So for instance, for week 1, we would write -2 times 1, right? Instead of x, we're plugging in the 1, plus 20. Well, that value is 18. So the residual on week 1, right, it's our measured value minus our predicted value. So it is 19 minus 18, which is 1. Okay, let's do this for week 2. So for week 2, our predicted value is -2 times 2 plus 20, which is 16. And the residual is 15 minus 16, which is -1. Similarly, we're going to go ahead and keep doing this for all of our data points here. Oh. Okay, and now we're going to graph our residuals. So for week 1, our residual was 1. For week 2, -1. For week 3, -1. Week 4 was a -1. Week 5 was 0. Week 6 was 0. Week 7 is -1, and week 8 is a 1. So we look at this graph and we can see that the residuals are fairly evenly distributed with no clear pattern. So that tells us that our model is a good fit. Okay. Let's look at a second example here. So in this example, we have the equation y equals 0.2x plus 38, which models the ages and salaries of 8 employees at a company. And we want to determine if our model is a good fit. So I'm going to go ahead and pause my video here and fill in this information in the table. You go ahead and pause your video and fill in your information, and we'll check back in a few minutes to determine if we're doing it correctly. Okay, so I have my table filled out with all of my data in it, and now I'm ready to make my graph. But notice that I don't have any numbers on my graph, so I'm going to have to fill in my numbers. Now, my y values, which are my residuals, go from, it looks like, between -4, and then I've got a 5 up here. So I'm going to go ahead and make these worth 2 each. So that'll be a 2, and that'll be a 4, and that'll be a 6. -2, -4, -6. Now, my x values over here range between 35 and 55. So I'm going to need to put a break in my graph, and then I'll start this at 30. We'll start it at 35, actually. So 35, 40, 45, 50, 55, 60 it looks like. Okay, so I'm going to go ahead and plot my residuals. So 35, negative 3, 37, negative 1.4, 41.8, 43 point, 3.4, I'll be up in this area somewhere, 45, 5, oops, out up here, and then we have 47 and 3.6, 53 and 0.4, and 55 and negative 4. Okay, we can clearly see a pattern here, right? An up and then down pattern. So there is a pattern in the residual graph. So the line is not a good fit. All right, we need to talk about how to find lines of best fit, but before we do that, we need to build up some vocabulary. So our next topic is we're going to use technology to find lines of best fit, but first let's talk about linear regression, what exactly is a line of best fit, and the correlation coefficient. So linear regression is a method for finding a precise line of fit. In fact, it's going to be the line of best fit. Okay, so what is a line of best fit? Well, the line of best fit is the line that minimizes all of those residuals. Okay, so it's the line that makes all of those residuals as small as they can possibly be. And whenever we have a line of best fit, we have what's called a correlation coefficient. So this correlation coefficient is a value that tells how closely the line models the data. Now, the correlation coefficient is going to go between -1 and +1. So if we have values that are, the correlation coefficient is exactly -1, that tells us we have a negative relationship and we have an exactly straight line. Now we keep going, right? We still have a negative relationship, negative relationship. Now when we have a correlation coefficient of 0, that tells us that we have no linear relationship, okay? Now we keep going up to the positive side, right? And when we get up here to a correlation coefficient of exactly 1, that tells us that our data lies exactly in a straight line with a positive relationship, meaning that as the x value grows larger, so does the y value. In the next segment, we're going to talk about finding lines of best fit using technology.